In Sydney, Australia, an industrial army is called into action.
No one has ever embarked on the scale of what we're doing here.
Deep out of sight, beneath the harbour city, a battle unfolds.
There's constant problem solving. Every day there's new problems, there's new issues.
Battalions of engineers pit giant machines against rock and mud to drive a new metro system through the beating heart of the city.
We have to get there, there's no other way.
The stakes are high and the clock is ticking.
You've got to take every bit of luck you can get, don't you, in this game?
This is by far and away the biggest public transport project in Australia's history. If I'm honest, I probably didn't quite know what I was getting myself into.
Got the problem?
Under the heart of Sydney, construction of the city's massive new metro forges ahead against the clock. 40,000 workers battle to create a $50 billion game changer to tackle the city's traffic nightmare. When it's complete, this new driverless railway will have dozens of new stations, more than 150 kilometres of track, and create a giant loop around Sydney. 8 monster hard rock tunnel boring machines, or TBMs, are digging more than 60 kilometres of tunnels beneath the city, beneath towering skyscrapers, and to the edge of one of the world's largest harbours. And now, the 9th tunnel boring machine, known as Kathleen, is about to embark on the most dangerous mission of them all, digging under Sydney Harbour. At the Barangaroo site, months of planning have paid off. Kathleen's giant pieces have been transported halfway across the world, across the harbour, and across a busy road, carefully lowered down a shaft to be reassembled in her launching cavern 35 metres underground. Kathleen is now ready to go to work. Her mission? To bore an 884-metre-long tunnel deep beneath Sydney Harbour itself. Twice. Not only will Kathleen's team be working almost 50 metres under the surface, they'll be operating in challenging geological conditions. Instead of friendly Sydney sandstone, they face soft mud and clay sediments, potentially shifting, unstable, and prone to collapse. Despite the dangers ahead, Kathleen's team is fired up. Her operators, Daniel Hill, known as Red Dog, and Adam Griffith, known as Griffo, are ready to go.
It's pretty much where the magic happens.
Yep.
We steer the shit from, so...
Yeah, this is the business end. Yeah, steering wheel and your pressures off your screens, which you can see what you're doing. Might put more pressure on the bottom to go up than on the top, and more pressure on the left than the right to go right.
And the panic button?
There actually is a panic button.
Right here, panic button. Yeah, that's when you're well and truly stuffed.
Red Dog jokes. But the refuge chamber is serious business.
If something happens behind you on the machine, because you do not have an exit point, this is where we'll be ending up.
The biggest thing is mainly a fire behind you. So this protects you, like the smoke, because yeah, if there's obviously the smoke, you can't breathe, and you're in too far, again, you can stay in here for 36 hours.
Kathleen has been specially designed for the bottom of Sydney Harbour and is known as a slurry TBM. Her front end is highly pressurised to stop mud and water from flooding in. Without it, the dig would be impossible. But working with high-pressure machinery deep underground is an extremely risky task. Topside, Young engineer Jamie Chirk, on her first TBM, is deep in training with the rest of the crew.
It's wet and you've got...
Their instructor is Des Walters.
Mechanical sources.
Des has successfully led many pressurized TBM missions.
Grease responds with oxygen and can self-combust. So we've got to be careful about what actually goes in. Want you to go in your work clothes.
There are many things that can go terribly wrong on a pressurized TBM. Perhaps surprisingly, the greatest danger is not flooding, but fire.
Under pressure, the fire is quicker, it's harder to put out, it burns more readily and produces so much more heat.
Fire, fueled by pressurized air, will quickly become an inferno. The extra oxygen is like adding gas to the flames.
If the situation is urgent, we do what's called a rapid decompression. We open everything and we dump all the air and get you out as quickly as we can get you out. It would be a nasty thing to be in.
Fire and gases are the things that we are worried about when we are on a machine. And the end results of the fire will be a flood anyway. If you burn the machine, you will get the water in.
Jamie Chirk is understandably nervous of what lies ahead.
I guess we all knew we're all working in a high-risk environment, and if anything, this is going into compressed air is more higher risk than anything we have done. Well, I have done.
We can do whatever we can to avoid it, but if it happens, we need to be ready for that.
They have to demonstrate to me that they've got the ability to go under pressure on the TBM.
Des Walters means that literally. He wants to make sure that the TBM crew can handle being under 5 bars of pressure. This test chamber creates the same pressure that a scuba diver experiences 50 meters underwater. And the same side effects, like impaired judgment, caused by nitrogen narcosis.
Yeah, I'm keen to see what I'll be like being a little high. So, yeah, it should be good.
Vincent Ganay will join her in the test chamber. He has done this before, and he'll be there if she gets into trouble.
Jamie's gonna go well. She's a bit stressed, but she'll get better.
Her pants are a little bit big. Welcome to my world.
Okay, I've got a thumb. We're about to start compression. Ready to go?
Des Walters will carefully monitor the increase in pressure, or compression. This will ensure Jamie and Vincent have time to equalize pressure in their ears.
Stop, 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 stop.
If they can't equalize, as the pressure builds, their eardrums could burst. Jamie is having problems. She has pain in her ears and sinuses. But they press on. And Jamie begins to get the hang of it.
All good? Good, Jamie. That's the worst part over, mate. $20 meters. Once we get down to about 30 metres, we'll notice 2 things happen. The first thing is their voice will change because the air is so much denser, it doesn't resonate the vocal cords properly. You hear the laughter because they're just at 30 metres, they've just started to get the first signs of nitrogen narcosis, which is really just intoxication, the same as alcohol. She started right on the mark, right on 30 metres. She started to cackle. They're starting to feel pretty happy. 40 metres, guys. 49.
Welcome to 50 metres, guys. How's it feel?
Jamie, could you whistle for me?
No.
I'll give it a go. Come on.
I didn't try.
What, your whistle broken?
Yeah, I think so.
Okay, guys.
As soon as you get a chance, blow up a couple of those balloons.
The point of the balloons is to show what happens if they don't breathe properly on the way back up.
I'm going to leave bottom in about another 30 seconds, so just get ready if you get those balloons blown up so you can watch Boyle's Law in action.
Des tells them to imagine the balloons are their lungs.
As we reduce the pressure, the volume increases, and if they were to hold their breath, that could hurt their lungs.
Jamie's happy, and not just because of the lingering effects of nitrogen narcosis. She's passed the test.
You're a gentleman.
Jamie did well. That's what's important.
Yeah, I wasn't sure if I could make it, but I did, so very good.
Right in the middle of Australia's busiest rail hub, Central Station, Construction Director James Pearce and his team have started excavating the new metro station. But now they run into some trouble. In the dead centre of their dig, they discover uncharted graves, some with human remains.
So we've dug up some things, we've brought in a team of archaeologists, and we're now stopped in the area. Unfortunately, we've got to quarantine the area, hand it over to the archaeologists, and they'll do their work on it, and hopefully hand it back to us pretty soon. Fingers crossed.
It's a major setback. James stops nearly all work on this part of the site, while archaeologist Ian Stewart and his team excavate the graves.
We're acutely aware of the time pressures, and we're actually trying to do this as efficiently as we can, but obviously this has really delayed their project.
Adele Zubritska and Natalia Hunt are sympathetic to James and his team. But until the graves are excavated and any bodies exhumed, archaeological trowels take precedence over the metro's shovels.
We are excavating in a very old area of Sydney. Although a new railway network is very important, it's also important to record and respect our history.
There might still be people in Sydney who are related to these people, so I think there's a real attachment, and it says a lot about Sydney's history.
The first railway station on this site was opened in 1855. Next door was a cemetery, consecrated in 1820. When construction of the new, much larger station began in 1901, the cemetery had to go. Relatives were given 2 months to have their loved ones' remains removed. It was a ramshackle process.
They didn't do a perfect job, let's put it like that, because if they did, we wouldn't be finding any bones at all.
Some skeletons were crammed 10 to a coffin before being relocated to other cemeteries across Sydney.
You can imagine that sometimes they might have grabbed only the largest bones that were visible, so we're here to collect what they left behind.
In all, about 30,000 graves were exhumed at the start of last century.
Some of them may have been missed, some people might have gotten a little bit lazy, some people might have decided that taking half of the body was as good as taking the whole body.
During the excavation, 160-year-old remains are unearthed. The grave is marked with a metal plaque. Joseph Thompson. Local historians track down Penny Russell, his great-great-great-granddaughter.
Born in 1779, he died in 1858 in his 80th year. As they always kindly say, he didn't quite make it to 80.
Penny meets with the Sydney Metro team and members of a historical society. They need to decide what will now be done with the remains.
I'm not too fussed in some ways about what happens to the bones, as long as they're treated with some, suitable level of respect and care, and they're returned to the earth in something as close to as possible to what his family would have wished at the time.
At Martin Place, Senior project manager Will Freelander and his team are making far better progress. They've demolished 2 towers, but now obstacles buried beneath their feet are the next challenge. Not graves, but tunnels. A maze of tunnels. 2 existing railway lines that feed the eastern suburbs of Sydney, 2 new metro tunnels, and a pedestrian tunnel, all intersecting right beneath this planned 30-storey building. It's Will's job to install huge foundation pillars to support the new tower. But there's precious little space to put them.
It was a really difficult operation for the designers to come up with the location for these piles with the amount of things that we're trying to dodge here, both our station that we're building and those eastern suburbs lines. So we come within 2 metres of the existing eastern suburbs rail lines, and we actually come within 500 mil of the tunnels that we're constructing at the moment down there.
But it's about to get even more risky. The pillars need to bear the weight of the new tower, but they can't put pressure on any of the tunnels below. So Will's team needs to construct specialised foundation pillars to support the building.
You can see behind me one of the steel reinforcement cages being lifted for the deep foundations that we're constructing here. So the cage there is one of several that will be installed in that single pile, in addition to the steel reinforcement. And then we have enormous steel plunge columns, we call them, which are solid steel members that are actually coming to site in its full length.
A super long and strong plunge column forms the spine of each massive pillar. Each column is lowered into enormous steel tubes bored into the ground. The plunge column will then be encased in reinforced steel and finally concrete.
All the load from the building will go down into the base of those piles rather than as the building sees side load from wind, it won't be imposed on those rail tunnels that we're spanning over the top of.
Just getting the plunge columns onto the site right in the middle of central Sydney is a challenge, and one is arriving tonight. It's 30 metres long and weighs 56 tonnes. So Will has called in one of the most powerful cranes in Australia.
That tower crane is basically the only piece of equipment that's able to lift those huge columns off the street, get them down into the site, and it'll be used to stand the column from the horizontal position, lift it vertically, and then lower it down into the excavation.
It's full steam ahead for the construction and assembly of the new driverless metro trains.
It's a tremendous opportunity for us to provide Sydney's first automated train.
But Jim Morris knows the deadline is approaching fast, and there's a lot to do before these trains can get on the tracks.
So Sydney Metro is 22 train sets, with each train set having 6 carriages. You have 3 different types of carriages. You have the driving trailer car, then you have a motor car with pantograph, and you have a motor car itself.
550 people work in this factory, but they'll all need to keep up the pace to finish the 132 carriages in time.
We have got a capacity now ramped up to 20 cars per month. So every 1.5 days, a car moves from one workstation to the other workstation.
The process begins with the car body shell construction.
So we receive individual piece parts which are welded together into sub-assemblies that form the underframe, the sidewall, the roof, the end walls, which is the car body.
The next step is the all-important high-pressure water test.
So we seal all the openings of the train to be able to test the train to make sure it's watertight. Then we also do all the electrical installations, all the running of all the cabling, all the electrical equipment that's installed above and below the carriage itself.
So it moves from station to station progressively, and once the car is completed, you have the integration of the car with the bogie. The bogie is basically your assembly of your bogie frame with the wheels and axles and your brake discs. Then it moves into testing to make sure that we take the bugs out of the system before the trains are delivered to Sydney.
With only a few months to go, the team now works in 3 shifts over 24 hours a day to make their deadline. After midnight, with the roads almost empty, a giant steel column heads towards the city centre. The first 59 kilometres are easy enough. It's the last kilometre that worries Senior Project Manager Will Freelander. It's heading here to Martin Place.
This is one of the tighter corners that we've got to navigate here, so the beam's going to come off Bridge Street and up the street here before then turning up and going up towards site.
The delivery has only been approved if it doesn't come within a metre of any building.
We try and allow a metre minimum clearance as we come around the corners. It's not much when you consider we may also have to navigate past parked cars. We plan on not touching any building or structure as we come in.
The first corner is a tight left. The chains holding the beam in place tighten under the strain.
You can see the axles on the back of the rig there steering independent to the main truck. Operator in the back car there controlling things.
One corner down, 2 to go. The next is another left turn, but even tighter.
We've done the first side corner, just coming around one of the tightest ones now. Good to see no parked cars or extra issues we're dealing with tonight.
The steel column just manages to get around this corner as well. But it's fast running out of angles. Will's big worry is that it could get stuck in the maze of narrow inner city streets.
So that was one of the tightest corners now. They're just adjusting the angle as they come around, ready to do the next corner.
It's the tightest of the lot. The rig reverses up, then aims for the bend.
It's all about setting up the truck now to get around this really tight corner into Bly Street here.
The turn must be judged to perfection, or the traffic lights won't survive. It's a critical moment, but it's through.
We're just heading into sight now. We've navigated those corners and that's it. That's all the hard stuff done.
Mission accomplished. The men behind the wheel are happy. Frank drove the front of the truck.
Didn't get a red light down Parramatta Road. I've never done that in my life. How's good that, eh?
Fergus, the back.
Yeah, all happy. Got here in one piece. Ready to lift when you guys are.
Will is relieved. Nothing hit, nothing damaged.
So I am a happy man. It's now 2 a.m, so I've got a couple of hours sleep before the day shift starts again and we get to start planning for the next hurdle to overcome.
Hold it there.
Back at the water's edge, back at Barangaroo, tunnel boring machine Kathleen is ready to start her historic voyage beneath the harbour.
As long as that aircon's set on 18, it'll be all good.
Next he's going to want a coffee machine.
Hey? Who do I speak to?
That guy.
For Red Dog, Griffo and the crew, it's showtime.
Finally D-Day and we get to launch it and get going.
The perils of the ancient clay sediments and the mud await.
It's very comforting to see that we have these experienced heads as part of our crew in Daniel and Adam. In the event that, you know, God forbid, something does happen, calm, cool, collected, we'll get through it.
Yeah, a little bit nervous. I hope it all goes well, of course, but whenever you actually start excavation, you do end up finding a few more little issues along the way before the machine's buried and everything's happening. So, yeah, a little bit anxious about that, I guess, but yeah.
First time TBM engineer Jamie Chirk is ready to take her place on the machine. She's not installing the concrete tunnel lining or operating the machine. Her job is to constantly check the tunnel is being built according to the design.
So I've actually have no experience with the TBM so far, and I like to think, because this is all so new, to make sure I do all the right things and I'm not the reason for them to stop.
She's going to be very unfamiliar of what parts move and what don't, and she'd have to be told quite clearly where she can and cannot be at certain times and whatnot. But she's a smart cookie, so she'll work it out.
There's certainly one place no one can be once the machine starts boring. and that's between the rock face and the cutter head. Red Dog does one final inspection before the pressure begins.
To begin with, we've got solid sandstone, so these come in handy, but once we get into the softer stuff, we've got mainly all the buckets and the teeth, and as we go into that stuff as well, if we've got to come in here and change them, that's where we match the same pressure for the cutter head as it is for the water pressure that's coming into the machine.
This pressurized cutter head is the only thing that prevents the soft sediment in the middle of the harbour from collapsing into the machine while they dig forward.
And the last thing you want to do is put a hole in Sydney Harbour and connect it. Otherwise, you'll be making the news for all the wrong reasons.
When they're tunnelling deep under the ground, safety is always first, but the work they're doing is some of the best skills required around the world to actually bring these projects to fruition.
Kathleen is fired up. Into history she heads. Deep beneath Sydney Harbour. Back at Martin Place, it's time for the new tower's foundation plunge columns to be installed. It's like threading the eye of a needle, where the needle is 30 metres long. One of Australia's most powerful cranes has been brought in. Months of intense planning have gone into this operation, which is led by Site Superintendent Brian Marshall, who lifts the lid on the challenge ahead.
So looking just inside the pile itself, we have a steel tube that runs on the outside that goes 27 metres deep. That then has a steel cage inside that protrudes out the bottom of that casing that takes the pile itself down to 40 metres deep. So this is 18 months in the planning to actually get these beams in and installed and concreted in.
Brian is feeling the squeeze. Below, the new metro tunnels are being dug. One tunnelling machine is just metres from where the plunge column will end up.
The road header is cutting through here at the moment. It's cutting past this pile now, and it's about a metre away from where we're standing directly below us by 16 metres down. Normally you wouldn't go that close. You want to stay as far away from the piles of a building, especially a high-rise building, as you can. So we're just about to lift the plunge column upright and then place it into the hole.
The first plunge column is raised, taking great care that the 30 metres of steel doesn't begin to rotate or swing.
The beam is designed to be lifted in this direction. If we lift it out of the right direction, it could actually put a bend in the beam, which we don't want.
Brian is on tenterhooks.
It should take around 15 minutes for the beam to be lifted up and placed into position in the subframe that holds it up there.
So far, so good. Next, before the column descends into its hole, every last bit of dirt and grime must be removed. The concrete must later set around it perfectly snug, like a second skin. Corrosion would be catastrophic. Time to thread the needle. The first few meters are critical. Everything must be perfectly aligned. Any twisting or buckling, and it's back to the drawing board. The plunge column drops into place, narrowly avoiding the maze of tunnels below.
So now they're putting in the locking pins that actually locate the beam in the right position. We don't want it to be off plumb at all, because if you imagine if it's out by 20 mil at this point, if you go up 30 stories, that'd be magnified into around half a metre off at the top.
Some final adjustments, and it's there.
Touchdown. It's in location. Now all we need is a surveyor to come and tell us that it's in the exact location that we need.
The surveyor gives the plunge column the all clear.
Great job in getting it in there. Now we're going to lock it off into position and prep it for the concrete works. Job well done by the boys.
But Brian is not finished yet. The concrete works first needs to pass the slump test. A set amount of concrete is dropped, and the amount of slump or spread is measured. This checks that the concrete is exactly the right viscosity to fill the entire hole, with no air gaps that could weaken the foundation. The concrete gets the thumbs up and is poured down into the hole to secure the plunge column in place. When the concrete is set, it's tested again.
There's a probe in this tube here and a probe in the other one over there. And what it does is it sends a signal from that probe to this probe. And if it's good constant concrete, then the signal should take a certain amount of time to get from one to the other. The little yellow one measures the temperature of the concrete. So we can see what temperature the concrete gets to over the 7 days between it being poured and when we do the sonic logging testing.
What happens if the concrete fails the sonic logging test?
That's not going to happen. You'd have to redesign the building just about to reposition one of these piles. And the problem being, the reason that there's only 3 of these piles is there was only 3 locations that we could put these piles in that weren't going to hit the existing or the new rail tunnels that we're putting in.
Luckily, the concrete passes the test, and the excavation of the massive Martin Place southern shaft goes full speed ahead. Out in Sydney's northwest, almost all of the new metro line will run underground in twin 15-kilometre tunnels. But one section won't. West of Bella Vista, 4 kilometres of track needs to cross a floodplain. So engineers have decided the line will run above the ground, 13 metres above, along a viaduct. This means 2 new stations will also need to be elevated. This part of the project is called SkyTrain, and most of it will be built by 2 horizontal cranes, known as launching gantries. The machines have just arrived from a massive roads project in Dubai.
There are several different types of challenges. We must be always ahead of the game, working at height, so safety to be controlled in a very strict manner.
First, the cranes have to be assembled about 20 meters above the ground, balanced on top of some of the 120 concrete piers they will move along to build the SkyTrain's deck.
We actually put up that piece and the other end piece at the same time.
We are going to use 2 500-ton cranes that they will work in tandem, and they will support the operation of setting the truss on the rails.
Giuseppe Mafrica is responsible for this task, and he's not happy. The wind is his enemy, and it's starting to blow.
So one of the main factors that can affect the job will be the wind.
If there is too strong wind, of course, we cannot erect. Normally, we stop if the wind is stronger than a certain limit.
For the moment, wind speed is just under the limit, and the lift gets underway. The first attempt to land one of the 6 giant trusses on top of the wheels fails. The wind is a real problem. They try again. This time, the wind drops just in time. And it's there. 1 down, 5 trusses to go. It gets easier. Soon, the major part of the lift is done. The remarkable thing about the gantries is their speed. Already, many of the concrete piers that will support the viaduct's deck have been installed. Temporary wheels on top of the piers will allow the crane to slide from pier to pier, using them like giant stepping stones as it moves forward. It begins here, where the viaduct just starts to leave the ground. A precast segment is delivered. It weighs 90 tons. It's hoisted up by the gantry crane with ease. It's shifted over into position and slotted down securely on a temporary steel frame to hold it firmly in place. One by one, the crane hoists up more segments until it's suspending 10 of them, a combined weight of almost 1,000 tons. Now comes the most critical part of the process: pulling all the segments tightly together. Steel cables are threaded through the segments, which are then tensioned tightly together, creating a concrete span as strong as if it had been poured as one piece. Once they've launched, tunnel boring machines, or TBMs as they're known, require many thousands of concrete segments to build the new metro tunnels. Each TBM needs up to 1,100 of these crest-like pieces of concrete every week, so they can keep moving forward. To keep them fed, more than 140 people in vast concrete segment factories work around the clock to produce a segment every 6 minutes. The largest factory is at a tunnelling site in the suburb of Marrickville, where nearly 100,000 segments will need to be made. Each weighs up to 4 tons and is designed to last at least 100 years. So high tensile steel wires and polyfibre are added into the concrete mix for extra strength.
Every segment has a unique barcode that tells us what type of segment it is and when it was manufactured, and that's scanned both over in the precast yard and then here, and then also on the TBM.
And because the segments have to fit precisely, it is critical they're delivered in the correct order. Get it wrong, and the TBM grinds to a halt while the correct pieces are found and delivered underground.
We have a guidance system which tells us the exact placement and the angle that the segments must be placed so that we can guide the TBM.
Each concrete ring is created by assembling 6 segments, but they are not symmetrical. Every ring is tapered, with one edge slightly shorter than the other. When the tunnel needs to run straight, the tapers alternate. But if the tunnel needs to turn, one tapered edge meets another. Aligning the tapered edges turns the tunnels.
It's important that we keep track of every segment that goes into the tunnel to ensure that the correct segment has been installed in the correct place. So we'll load this TSB.
Not all of these segments are destined for the tunnels at Marrickville. 6 at a time are loaded onto trucks and transported to other tunnel boring machine sites around Sydney. This delivery is on its way to Chatswood on the North Shore, crossing the famous Sydney Harbour Bridge, where the segments are offloaded by a crane and successfully lowered into the site. Back at Barangaroo, the TBM Kathleen crew have been making steady progress, digging deep below the harbour.
240 metres in, 140 rings. Yeah, go along nice and smooth, making good progress.
Yeah, everything's tickety-boo at the moment.
Engineer Jamie Chirk, on her first TBM, has left behind any nervousness at Barangaroo.
I'm quite busy actually in a shift. If I could clone myself, I'll be in 10 places at the one time. Yeah, we've been doing really well, and actually our managers were telling us how surprised everything's gone really smoothly, so very happy with that.
But suddenly, they have to stop boring. They've hit a layer of dense clay, which is clogging up the cutter head. Thankfully, there's no water. This means they can still enter the front chambers to clear the cutters.
It's fine, I'll just take it.
We'll sort it out, we'll get the bentonite mixture right, we'll only get better from here.
Bentonite is what makes Kathleen different from the other tunnel boring machines. It's why this type of TBM is called a slurry machine. When the hatches are closed, the front of the TBM is pressurized, pumped full of liquid bentonite and high-pressure air. It pushes against the pressure of the mud and clay and stops it from flooding into the machine. The bentonite creates a slurry as it mixes with the material being excavated by the cutter head. The slurry is pumped out of the excavation chambers and travels along an ever longer pipe to reach the slurry treatment plant. Here, the excavated material, or spoil, is extracted from the slurry. The spoil is barged away. The bentonite is recycled. It's then pumped back to the TBM to be used again. Through the sandstone and the clay, Kathleen has made great progress. But now, it's the moment of truth. The sandstone is behind her. Ahead lies the trickiest part of the harbour, the ancient river channel.
So we've cut out of the sandstone, through the clays, and now we're in this band of organics, and yeah, it's 4.5 bar pressure, which is pretty high pressure.
It's very, very soft, so you have to be very careful making sure the TBM is steering in the right direction. Because it is so soft, the machine has a tendency to sink.
If you drop the pressure, the water would just race in at this point, absolutely race in. It's a bit of a critical time, it really is.
Non-negotiable today is be fit for duty, make sure you're not fatigued, and just be careful down there, and that's it. Have a safe one.
Griffo only spends half of his shift on Kathleen. He splits his time between the TBM and the slurry treatment plant.
I must walk 20 k's a day without any problem at all. So every day it's a little bit further when you're coming in.
At the plant, Griffo takes a look at just what they're boring through now they've left the sandstone behind. It's far less solid and far less stable.
It's almost like soil. Lots of seashells, lots of broken down plant matter. Chemistry is a little bit different, so it's a bit harder for this plant to deal with it.
Tunnel boring machine Kathleen is now mired in this sludge. It is ahead of them, behind them, beneath them, and above them, pressing down. It's an anxious time.
Yeah, we're coming to almost a halfway point right under the middle. So we've got 5 bar head pressure in the bubble chamber.
5 bar is close to the maximum pressure for the best operation of the machine, pushing to the limit to stop the mud that surrounds them from flooding into the machine. Red Dog says the high pressure chambers at the front are now too dangerous to enter.
Because there's so much pressure on the head, we can't actually go in the front cutter head at the moment. Even under hyperbarics, it's a little bit too high.
It's just changing that quickly, the material.
But suddenly, there may be no choice. Something has gone wrong up front inside the chamber. A piece of the giant cutter head has come loose. It's shown up in the slurry treatment plant.
Just making a joke to the guys. It's like, it's Friday the 13th, so let's see what happens. And literally, the foreman walks in and brings us this wedge and tells us it's what he just picked up from the slurry treatment plant. We then made the decision to immediately stop the tunnel boring machine and to prepare for an intervention.
The wedge secures the cutter wheels in place. It needs to be replaced. Otherwise, the cutter wheels risk coming loose and causing major damage.
It's like a 400-kilo piece of steel that falls into the cutter head. It gets turned around with the cutter head, and it can create a fair amount of damage, destruction.
In spite of the risks, someone needs to enter the pressurized cutter head, find out where the wedge has come loose, and survey if there's damage.
They say they are not both together.
The mission goes to a select team, including Michele and Vincent.
Sounds pretty simple, sounds pretty easy. However, you're under enormous time pressure.
They have less than 60 minutes to complete the job. Or else they will have to spend hours in decompression to reduce the risk of the bends.
Okay, here we go. It's 1404.
Vincent and Michele enter the hyperbaric chamber. They wait while the pressure is increased to match the pressure inside the cutter head. Once equalized, they get to work. Michele heads into the cutter head, his voice already affected by the pressure. Vincent remains in the bubble chamber. Michele brings a camera. This is very rare footage. Few people have ever seen the inside of a cutter head while it's in the heart of the clay and mud.
Vincent!
Michele starts checking the cutter wheels one by one.
I need some water, mate.
He's looking for the 4 double cutters.
This is good.
The cutter head is more than 7 meters high. And everything is covered in sludge.
1, 2, 3, 4, okay.
Vincent controls the flow of a hose from inside the adjoining chamber.
Give me back the water. All right, good.
Suddenly, Michele is hit by the water spray.
Vinny! Vincent!
Soon, they have only 12 minutes left. Michele and Vincent need to get to the decompression chamber soon.
The problem is here. We have the wedges here. Yeah, I found it. It's number 5 and 7. 5 and 7 is missing here.
And there's more good news.
The cutter is still here.
The cutter wheel hasn't been damaged.
Just the wedge. The rest is okay.
Mission accomplished.
Okay, I'm coming up.
Another team will now enter through the second hyperbaric chamber to replace the missing wedge. And after almost 2 hours of decompression, Vincent and Michele are back.
Vincent is a funny guy, and in some point he started using the spreading water on me while I was very concentrated finding the problem, but it's part of the job. We have this funny moment as well. Well done.
Next time, as Kathleen continues to battle the mud, ominous signs appear that something has again gone wrong.
Bubbles are not good. It means that something is going wrong.
A part of the SkyTrain suddenly cracks.
We are trying to understand what is going on.
And teams race to complete the first line so the driverless trains can start running.
We're going to move that out in the stabling road. That's ready to rock and roll for its movement testing.